Hi, third grade. We are on our final chapter in math. This is chapter 14. I'm going to go over lesson 1 with you today. I'm going to do some hands-on stuff. At least I am. I'm going to show it to you. And we are starting geometry. So let's get started right away. And we've got a lot of vocabulary on this page. If you look, you can see a lot of yellow highlighted words. So let's get to those first. It says, an angle is made when two rays share the same endpoint. A ray is part of a line that has one endpoint and extends in one direction without ending. An endpoint is the point at the beginning of a ray. The shared endpoint is called the vertex. So just in this paragraph alone, we have 4 vocabulary words, and we're going to get another one as we scroll down a little bit. So let's talk first about what is a ray. All right, a ray is simply, we have an endpoint right here, just that dot like that, that's the beginning. And then a ray is a line, and we put an arrow on it to represent that that line is going to continue on and on and on. We can't draw it on and on and on. So the arrow represents that it is going on. Now a ray can go in any direction. I can have it here, and it could angle up this way. I could have it here, and it goes this way. I can have my end point here, and it can go this way. So a ray can go in any direction. So it has an end point. That was one of our vocabulary words. An end point here, and it goes out in any direction. The arrow's telling us and representing that it goes on and on. Now sometimes we have rays that share the same endpoint, and it might look like this one down here at the bottom. Here we have an endpoint, but look, we have a ray going this way, and we have a ray going straight up this way. Now when they share an endpoint, that fancy name for that is vertex, that fancy math name. It's called the vertex. And when that happens, when we have an endpoint or a vertex right here that the rays are sharing, it creates something in it called an angle. Now, if you look at this one, you might notice right away and you say, oh, Mrs. Shreddy, that angle actually kind of makes a square right there in the middle. And that's true. We call that a square corner. And we're going to, as we scroll down and you look at the towards the bottom of this page, you're going to get the fancy math name for that too. This one created, these two rays created an angle that is actually called a square corner. So that was a lot of vocabulary in there for something that's not too difficult. So here we had an endpoint or a vertex that was shared by 2 rays. Now remember, those arrows kind of represent that those rays are continuing on. Okay? So let's go down to this build it section, and I will pull this up, and let me erase what I did over here real quick. And it says, use a geoboard and pattern blocks to explore angles. Now, you might have a geoboard at home. You might not. Probably not. I don't have any at my house, but I got some ready here at school to show you. It says, use a rubber band to make a large square on a geoboard that is similar to the orange pattern block. So I did one here. Here's my large square right here. And it says, use an index card to compare one angle formed by 2 sides of the square. An angle that forms a square corner, there's that term that I used just a minute ago, is called a right angle. Okay, that's the fancy math term for square corner, right angle. Now, let me see. Let me get my index card. So what they're saying is, if I put my index card down here in the corner of my square on my geoboard, you'll see that the rubber band lines up nice right along the bottom, and it goes right along the edge on the other side. And on the board, let me show you, you can see that when they put their index card down in that corner, look what happens. Here's that ray, kind of like the one we just looked up at the top. Okay? Oh, sorry. Miss Shreddy's not. There we go. It made a square corner. Well, the fancy name for a square corner is a right angle. Now, it can go in, we've looked at it this direction, like this. Sorry, that's not very neat. We look that way, but it also can go in this direction, like that. So a square corner doesn't have to necessarily just go this way. It can go in any direction. So here we have a square corner. And our question is, do all four corners of a square form right angles? Yes, it does. Because look, I can put my index card here, and it lines up along both edges. I can put it over here in this corner. I can put it up here in this corner. And I can put it over here in this corner. And they all line up perfectly. So, do all four corners of a square form right angles? Yes. Yes, they do. And so does my index card, which is actually a rectangle. It has 4 right angles to it. All right. Very good. So let's go on. Let me erase this. And we will move on to the next page. Let me click over. Scroll up. All right, so let's look at this one. Use a rubber band to make a large triangle on a geoboard that is similar to the green pattern block. Yep, you guessed it. Mrs. Shreddy has one ready. Let's see. So here's my triangle on my geoboard, like the one in the book. It says use an index card to compare one angle formed by 2 sides of the triangle. So if I look at this angle down here, because again, if you stop and think about it, here's my end point or my vertex. I have my ray going this way. Now this time though, look, my ray is going to go up through. It went through the card, didn't it? Look at that, because here's the card over there. And if I put it up here on my geoboard, you'll see what I mean. It kind of shoots back behind the card, doesn't it? So that doesn't work for a right angle, does it? So if we look, it says, I'll read this again. Use an index card to compare one angle formed by 2 sides of the triangle. This angle is less than a right angle. Why is it less than? Well, here's my angle down here. Okay? In a square angle, it would have had to come clear out here. But it's smaller than that. So it's less than a right angle. It says how many angles in this triangle are less than a right angle? Well, I can look at this and I can see this isn't a right angle. It's smaller. And this angle is not a right angle. It's smaller too. So in this particular triangle right here, I have 3 angles that are less than a right angle. All right, let's look at our next one. I will scroll down. Let me put this over here. Erase the board. All right. Now, use a rubber band to create a large hexagon on a geoboard that is similar to the yellow pattern block. All right. Here we go. Here's my hexagon, 6 sides. Use an index card to compare an angle formed by 2 sides of the shape. So this time, watch what happens. I'm going to put, here's an angle. This time we have 6 angles because it's a hexagon, 6 sides. I'm going to put my card down here in the first, this angle down on the bottom, like we've been doing. Okay? Now, it lines up nice along the bottom, doesn't it? But look at this side. In order for it to be a right angle, it would have had to line up nice and neat with this side. But look what happened. My line went way out here. It went way out here. And I can show you that on the board right here. Here's my vertex, one of them. And I had the ray that went out this way. And remember, it's showing it goes on. And then I had a ray, and it went clear out here, away from my card. Now, my angle that was made from those 2 rays is like this. It goes way out past my note card, doesn't it? So, this angle is greater than a right angle. Now, you can almost think of this as like an alligator mouth. And sometimes if you were in class, I would kind of be doing this with you. I would show you. If it's a right angle, you might want to think about if you put your hands like this. You have straight up here and straight out to the side to make that right angle. Now, if your angle is a little bit smaller and that alligator has its mouth closed a little bit more like this, then you have less than a right angle. But in this hexagon, which was the triangle up there, but in this hexagon, that angle was like this, like it's really got its mouth open. So when it's like this, we know that the angle is greater than a right angle because it wasn't here, it was way open like that. So it's bigger than a right angle, it's greater than a right angle. So on this question it says, how many angles in this shape are greater than a right angle? And no matter where I would put my card on any of the vertices there, vertices, sorry, they are all going to be greater than a right angle. So we have 6 of them. All right, let's scroll down. We have 2 questions down here. Let me erase the board. Can a triangle have 2 right angles? Explain. Now, the triangle we just looked at didn't have any right angles, did it? But let's stop. Can you make a triangle that has a right angle? Let's look. Let's kind of go back to what we had at the beginning when we first looked. We had something that looked like this. They showed us this. Okay, right? But let's look. If we wanted to make a triangle, we know a triangle has 3 sides. Let's take those arrows off for now. If I connect this side, this side to this end to this end, did I make a triangle? Yeah, right? And I have a right angle right there. Just like that. So, I know a triangle can have 1 right angle, but my question is, can it have 2 right angles? Well, if I look at this, I know that this is going to be less than a right angle and this one would be less than a right angle. So if I say, well, let me try to draw something and let's see. If I make 1 right angle like I did before, is there any way that I can make another square corner here? Okay, because there I have a square corner. And then, well, can I connect it like that? No, because now I don't have a triangle. I have 1, 2, 3, 4 sides. So now I don't have a triangle. Well, what if I did this again, and I made it like this, and then can I connect it anyway? No, I can't. So can a triangle have 2 right angles? No, because the sides would not end up connecting. Okay? And that's just one thing that you can say. There are other answers that would be acceptable. So we know that we cannot do that. It can have 1 right angle, but it can't have more than 1. Question number 2. Give a real-world example of a right angle. Okay, well, as I'm standing here just at my board, look, my eraser, right angles. This book, actually my iPad is on a book right now. The book, right angles. My index card had right angles. So as I look around the room, I see lots of right angles in here. So maybe you can write down something that you see in your house that has a right angle to it. All right, let's look real quick. I just want to kind of go over your practice it. I'm going to give you a hint. I'm going to show you this because I'm going to give you a hint. So your directions are, tell whether each angle shown is a right angle, less than a right angle, or greater than a right angle. Use an index card if needed. You might not need to, but if you have one laying around and you would like to check, you can. Or you might use your hands and kind of look. So they're going to show you where the angle is. here's the angle right here. So they want to know, is that angle, which we just kind of did this on the other page, is that angle less than a right angle, greater than a right angle, or is it a right angle? I'm going to give you a hint. If our book gives you a big hint on whether it is a right angle or not. Let's look at the next one. Look at number 4. Look at my angle. Look, did it make a square? Yeah, it did. So when you see the square, you know that right away, you'll know that it is a right angle. Okay, so the right angle should be pretty easy to find on these. You might have to think a little bit harder on some of the other ones, like here's the angle here. You have to decide, are they less than or are they greater than? And if you have an index card at home, that might help you. So work on those. I don't think it's too hard, too difficult. I think you should be okay with it. Take your time. If you need to go back and look at the first couple pages again before you do it, do that, okay? Miss everyone, and hope to see you all soon. Bye, boys and girls.